Welcome to the RHS pre-calculus presentation of converting rectangular coordinates to polar with Taylor and Ben and special guests Billy and his dad.
Polar and rectangular coordinates can sometimes be difficult to understand. Today we will look at the story of Billy Enkelsberth and his dad Waldo to facilitate the understanding of the enigma known as polar and rectangular coordinates.
One day, Billy and the patriarchal figure in his life, Waldo, were endeavoring to discover the source of the river known as the Mississippi. Suddenly, a piece of cosmic space conglomerate impacted in the immediate vicinity of Billy and Waldo. The energy of the collision was transferred into Waldo's body and launched him 40 feet east and 30 feet north. Let's assume in the resulting explosion, Billy's leg was fractured in 3 places, and his brains were slightly addled. As a result, he could only walk in straight lines and turn 90 degrees.
This situation lends itself to being plotted on a Cartesian coordinate plane as a rectangular coordinate, in which a point is defined by the coordinate x, y. X is how far the point moves horizontally on the x-axis, and y is how far it moves up and down on the y-axis. The vertical and horizontal movements are based off of a center point called the origin. In our case, the data forms the coordinate 40, 30. In order to find his dad using a rectangular coordinate as information, Billy would walk 40 feet east and 30 feet north.
This coordinate can also be written in another form called polar form. In both cases, the goal is to define where a point is. However, each uses a different method. As stated earlier, the rectangular coordinate is created by 2 measurements of how far side to side and then up to down it is. In polar form, a point is defined by the angle from the x-axis and from that angle a distance straight out. This is represented by r, theta. Imagine Billy's case. Instead of walking east and then north, Billy would turn until he is facing his dad and then walk straight to him.
In order to convert a rectangular coordinate to polar form, you must first plot the rectangular point and then draw a triangle like so. Then add the information you have onto the triangle. In this example, the legs will be 40 feet and 30 feet. To convert, we need to find the angle that starts at the center and the length of the third side. To find the third leg, we use the Pythagorean theorem, which states that in a right triangle, a squared plus b squared is c squared, in which a and b are the 2 short legs of the triangle and c the longest leg. Plugging in our values, we know that 40 squared plus 30 squared is equal to x squared. When these are multiplied, we get 900 and 1600. Added together, these are 2500, and when we take the square root, it's 50. This is how far Billy will have to walk to his dad once he is facing the right direction.
The angle can be found as theta equals inverse tangent of y over x. Plug in the value for y and x, and then use this equation to find theta, or the angle Billy will have to turn in order to look straight at his dad.
When we plug in 40 and 30 for our x and y, we should reduce the fraction. So we want to find the inverse tangent of 3 over 4. This is about 36 degrees. Combined with our information, we get the point 50, 36 degrees. However, this is not the only possible answer. There are, in fact, infinite possibilities.
For example, Billy could walk 36 degrees to look straight at his dad and then turn around completely and be looking the same way. This would be 50, 396. Or Billy could turn to face his dad, face backwards, turn 180 degrees, and then walk the distance backwards. As a result of these exception answers, they are usually limited to 0 to 36 degrees. Even with these limitations, there are usually 4 answers given any point.
Thank you.